In this video, we are going to examine the derivative at a point. First, let's recall what a secant line is. So if we have a function, let's say something like that. Say this is A on the graph, that's B. Then this here would be f of A. Right, and then that point there would be f of B. So the secant line is the straight line that passes through both of those points. Now what I want to do is I'm actually going to change now this from B to X. Then this will become f of X up here. So also recall the slope of a line is given by m equals rise over 1, which is delta y over delta x. So the slope of this secant line right here would be m equals f of x minus f of a over x minus a. Alternatively, if we let x equal a plus h for some h not equal to 0, we call this an incremental change, right? So h represents the increment change. Then what we can do is we can write the slope of the secant line in this form instead. F of a plus h minus f of a all over h. Okay? So both of these forms can be used, and in fact we will wind up looking at both forms in this video. Now recall that a tangent line of a graph, so let's try and draw the same graph. Yeah, that looks good enough. Let's say this is A, and this here would be f of A. So the tangent line at A is the straight line that intersects the graph at only the point A. So that's a terrible, let's see if I can do better. Alright, so it doesn't look like it, but it's only intersecting at that one point. Right, so it's just touching the curve at that point. So this is the tangent line. Now, the problem here is, what is the slope of this line? We don't have a second point for this line. Well, let's look at how we can form this line using secant lines. Right, so come back up to here. Well, now let's go ahead and take a look at, let's call this now, let's say this was x1. I'll write the 1 in green. Right, so let's now say, okay, let's this point be the point x2. Well, then we have a secant line that passes between those 2 points. Right, we can keep doing that. Let's see if I can add a color. Let's add purple. Oh, that's not going to show up too well. How will orange show up? Orange shows up pretty good. Right, so then we can do, okay, here. Oh, that's way too thick. I think I have them set up on the thinnest. And so let's say this here is now the point, a new point x3. Right, then we're going to have a point there, and we can draw a secant line through those 2 points. Right, until finally we have the tangent line given right at A. Right, so notice how we are forming this line, this tangent line. What we're doing is we're forming secant lines just by moving this endpoint what's happening closer to the starting point A. Well, isn't that the idea of a limit, right? We're sliding x over to A. That is precisely what a limit is. So in a sense, a tangent line is the limit of the secant lines. And so it makes sense to take the slope of the tangent line as the slope of the secant lines. Oh, I don't want red anymore, sorry. Slope of a tangent line. So let f of x be a function in an open interval containing the point A. The tangent line to f of x at A is the line passing through the point A f of A with or having slope m equals the limit as x approaches A of f of x minus f of A all over x minus A. Provided this limit exists, of course. Alternatively, we could also use the slope here. So take now this one here instead. Then h would go to 0, right? Because our increment change in A is approaching 0. So the slope would then be the limit as h goes to 0, f of A plus h minus f of A all over h. So either of these two slope equations works. We will also refer to the slope of the tangent line at A f of A as simply the slope of f of x at A. Now what we're going to do is we're also going to define this as the derivative. So it's the same starting, we would say that the derivative of f of x at A is defined by this, and this is read f prime of A. Right, so this little apostrophe up here is a prime. And we take it by definition to be the second limit formula. So limit as h approaches 0, f of A plus h minus f of A all over h provided it exists. And of course, alternatively, we could also use the other limit to write this limit as x approaches a, f of x minus f of a all over x minus a. Each of these formulas have their uses in terms of theory, so they can be used interchangeably, and they may be used interchangeably throughout the rest of this lecture series. So looking at this then, what we say is the derivative of a function is the slope of a tangent line at that point. Right? So it's the slope of the function at the point. That is what a derivative is. We will now conclude with a few examples. So we're given a function f of x equals x squared. We want to find the tangent line at x equals 3. So remember, tangent line, or rather equation of a line. There are two equations. We're going to use point slope form so that we can write it in slope intercept form. So the point we're going to be using, x naught, y naught, is 3 comma 3 squared, which is 9. Now we just need to find slope, and now the slope is the slope of the tangent. So what we need, limit as x approaches 3 of x squared minus 9 over x minus 3. This is the limit as x approaches 3 of x plus 3 times x minus 3 all over x minus 3, which is the limit as x approaches 3 of x plus 3, which is 6. So our slope is 6. So equation of tangent line, y minus 9 equals 6 times x minus 3, which is 6x minus 18. Add 9, we get as our tangent line y equals 6x minus 9. Next, we wish to find the slope of the function f of x equals 1 over x at x equals 2. Okay, so again, what we want is the limit now as x approaches 2, 1 over x minus 1 over 2 all over x minus 2. Go away. So this is the limit as x approaches 2, 2 minus x all over 2x, and then that will all be over x minus 2, simplifying. Yields that. Now what we can do is factor out that minus 1. Then we're left with negative 1 over 2x. Limit as x approaches 2, that is negative a quarter. And finally, given f of x, 3x squared minus 4x plus 1, we want to find f prime of 2. So that's just the slope at 2. So that's the limit as x approaches 2, f of x minus f of 2 over x minus 2. So we're still going to have that 3x squared minus 4x. Alright, 12 minus 8 is 4, plus 1 is 5, 1 minus 5 is a negative 4. Numerator can be factored. Right, so we're going to have an x, a 3x, then a 2 and a 2. That'll be minus, that'll be plus, all over x minus 2. So this is now the limit. X approaches 2, 3x plus 2, and that is 8. So that now concludes this video on the derivative at a point. In the next video, we are going to define what we mean by the derivative function.